Hello, let's go ahead and get started with 1.1, solving equations and inequalities. In this lesson, you're going to review how to solve multi-step equations, as well as we're going to learn what's called interval notation, which is very important. You will see interval notation used extensively in Algebra II trig as well as in pre-cal. We're also going to solve what's called literal equations. Literal equations contain multiple variables. For example, formulas in geometry like area equals base times height, solving that for base or height, and so on. Okay, let's first go over and review inequalities, and then we're going to learn what interval notation looks like before we actually start solving any equations or inequalities. Interval notation is just another way to write an inequality. Like, for example, when you go to an amusement park and let's say, a ride requires you to be over 4.5 feet tall to ride that ride. So that would mean that your height has to be greater than or equal to 4.5. So interval notation uses symbols greater than or equal to, less than or equal to, greater than, less than. And if you'll recall, greater than or equal to, less than or equal to means, of course, that you can be at that value or higher. You can be at that value or smaller. Greater than, if I say that the amount of money I earn in order to pay this bill has to be greater than $200 a month, then I have to make over $200. I cannot be at $200. And you're going to see when we start graphing solutions on a number line. For example, if I were to show on a number line, like you did, I'm sure, when you first learned about inequalities a long time ago, let's say you've got the value 4.5 on the number line. This particular value, you would have a shaded in hole at 4.5 because, once again, I've got the greater than part. I can be on that value. Then you would actually shade to the right because I can include any value above that. So when you see the part that has the equality, we're going to use closed in holes. When you see just greater than, less than, use open hole because you exclude that actual value. All right, so let's practice with interval notation. Interval notation also uses parentheses for values you don't include. It uses brackets for values you do include. Okay, so let's first look at some examples from a number line. So write the following set using interval notation. Okay. We'll say part A. All right. We've got this particular solution set. It's got an open hole at 2, and it's shaded to the right. Okay, so if we're wanting to write that particular solution set in interval notation, this is what you're going to do. Pick your farthest left point that it starts at, which of course is 2. See, it only goes to 2. And you have to determine, and you always, definitely, this is very important, always write interval notation, smallest to largest. Always write it in order, and you're going to understand what I'm talking about in just a second. So when we start at 2, and then it goes right, how far? To infinity. It's going right forever. It doesn't end. So we use infinity. Now, you always will use parentheses around negative infinity or infinity. And the reason is, think about it, can you actually touch infinity? Can you actually be on a particular value of infinity? No, you can't. So at 2, notice that it's an open hole. So in this case, I use parentheses. So parenthesis 2, because it's open at that value, that's my farthest left point on the number line that it goes, and it goes right forever. So that is how you would write this solution set, that's what we call it, in interval notation. Okay, so let's look at another case where it may be given to us in inequality form and not on a number line. So part B. Let's say I've got x is less than or equal to negative 1/4. I know you guys love fractions. We all love fractions, correct? Not really. Okay, and of course, if I always draw a number line, you're going to see me do that a lot, and throughout this lesson and the next lesson, it just helps me see it visually. So in order to put this, you're talking about all the set of numbers that are less than or equal to negative 1/4. Plot that. You can draw a number line. You don't have to, once again. So I'm going to point a point. I am going to place a point on the number line at negative 1/4, so approximately here. You have to think, do I use an open hole or closed hole? Well, it does include the equality part, so we're going to shade that hole in. And then you think, do I shade to the right or to the left? Talking about everything less than, so shade this way. Okay, that's just showing this set of numbers on the number line. We still have to put it in interval notation. So you have to think, and this is why I like to do it on number line, to visually see it. You have to think, how far left is it going? Well, it's going to the left forever. And recall, I told you to write interval notation always from smallest to largest, so negative infinity. And then it stops at negative 1/4. And then think, do you use a parenthesis or a bracket? I have a closed-in hole, so that gets a bracket. So there you go. Now where we're going with this, in a minute, we're going to solve inequalities, and we're going to get answers like this, and we're going to go a step further and put them in interval notation. So that's why we're covering this first. All right, one more to show you is a compound inequality where it's sandwiched together. Let me see if I can find a particular. This may be getting us ahead to the next lesson, but it'll be okay. Part C. Let's say I've got the solution set. Well, I'm going to show you two more. From negative 5, less than or equal to A, less than 0.5. So once again, you can think about it, and you, like I said, you don't have to draw a number line, but it just helps me. So I'm going to draw a number line, place these two values, So, of course, -5 will come before, we'll just say 0.5. So we'll just put those two values there. Then let's plot what we have. When your variable, so I'm going to look at just this part of it first. So let's not even pay attention to the 0.5. You actually have to start with your variable and read that backwards. So we're going to say a greater than or equal to -5. So we're going to put a closing hole at -5. Once again, this is, you've got to read backwards, a greater than or equal to -5. So I'm going to shade this way. All right, so that solution set would be going here. Then I'm going to look at this part where you have a is less than 0.5. So you need to, so just ignore this part. We're going to put an open hole at 0.5. Then we're going to shade, of course, to the left. Okay, so in order to actually put only the numbers that satisfy this inequality in interval notation, you have to think, where did the solutions overlap? Well, I know that they definitely overlap at -5. Notice that you've got it closed in with red, and the blue is coming here too. So it starts at -5. That's as far left as it goes. And then as far right as it goes is 0.5. Because it does not, the blue does not continue past 0.5. Now, the last thing you need to determine, do you use a bracket or parenthesis around these values? At -5, you have a closed-in hole, so we're going to use a bracket. At 0.5, you have an open hole, so parenthesis. And this is your answer in interval notation. It's going to be a little bit confusing to you at first, but I promise you, once you just keep practicing it and working with it, you're going to get better at it. You know, it's just kind of, you have to remember open hole, shaded hole, bracket, parenthesis, how far left, how far right, but you'll get it. Okay, now let's go ahead and take it up a step and start solving equations. So we're going to kind of, actually we're going to switch gears a little bit right now, solve equations, then we will go back to solving inequalities when we'll come back to interval notation. All right, solving inequalities. That one of the math concepts that is in just about every lesson that you do, every chapter. Solving equations. Very important that you always check your answers. Check your answers. As we progress into upper level mathematics, algebra 2 trig, pre-calculus, you're going to see these are not your normal algebra 1 equations as far as, you know, does this answer work in your equation? Sometimes you're going to get infinitely many solutions. So we're going to see what that looks like. And then sometimes, of course, you're going to get no solution. We're going to see what that looks like as well. So one type, when you get, this is what it's going to look like when you get infinitely many. Infinitely many, and you can say, sometimes you're going to see, well, I'm getting ahead of myself. All right, let me back up. So let's say that I've got 3a plus 5, and we're going to multiply that by 2, and then on this side I got 6a plus 10. Well, of course, if you distribute 2 first on this side to clear parentheses, you're going to wind up with 6a plus 10 equals 6a plus 10. And notice that you have the exact same thing on both sides. So of course that's like any number for A is going to work. You get a true statement. And of course if you got, let's say you went ahead and just, I don't know, wasn't paying attention and you just kept working it, you would see that your variables cancel on both sides when you get them together. But you don't have to, if you can see that you have the exact same thing on both sides of your equation, you don't have to do any more work because you know that any value for that variable is going to work. So when your answer is infinitely many solutions, you're going to get a true statement. You'll arrive at a true statement. And in interval notation, your answer will actually be all real numbers. So negative infinity to infinity, sometimes you're going to see double bar R, what they call it, used. So negative infinity to infinity or double bar R, or you can say infinitely many. Like those three choices will work. Okay, the next type is when you have no solution. No solution. So let's say that I've got the same type of example, 2 times 3a plus 5. But in this case, I have 7a plus 8. Once again, distributive property on the left side gives you 6a plus 10. On the right, 7a plus 8. Actually, hang on, let me change something really quick. Let's make that 6. So that it will be no solution. Okay, if I change this 6a, 6a. Well, let's get our variables on one side. So subtract 6a, 6a. Notice that when these variables cancel, you're left with 10 equals 8. 10 equals 8. And of course we know that is a false statement. So in this case, you would say no solution. And I always let you just abbreviate it, SOL. Or you can say the empty set. You'll see that in upper level math as well. Okay, so let's go ahead and start solving some equations. I know you guys love math so much. You're going to hear me say that, especially when you're in class every day with me. Okay. We'll just... All right, we're going to say solve and check. Number 1, 4x minus 2 Okay, when you have multi-step equations, recall you sort of follow order of operations. We definitely want to get rid of parentheses, combine like terms, and simplify it as much as possible. Get all variables on one side, all values, all constants on the other side, so on. So the first thing, and please be careful, I'm going to make a very important part, and you're going to feel like I'm insulting your intelligence. However, I see a very common mistake here a lot. So notice that the 2 has a minus sign or a negative sign in front of it, so it's considered negative 2. When you distribute, I would go ahead and take that negative sign with it. So this is going to give you 4 minus 2, and then negative 2 times negative x, positive 2x. And then equals negative 38. When you're working your homework problems on paper, when I have you submit them, please make sure your work is neat and orderly. These problems do require some work, so make sure you're showing your work as well. All right, then the next step, of course, is to get your like terms together. So 4x plus 2x, 6x. I would go ahead and add 2 to the other side. You can do multiple steps in one if you want to. You don't have to. If you're a step-by-step person, that's fine. Negative 38 plus 2 makes negative 36. And then x equals negative 6 when, of course, you divide by 6. Okay, so that solution came out to be nice, pretty, no tricks, nothing surprising. Number 2. All right, number 2. This is the equation that we have. Okay, there's a lot going on in this equation. Notice you have parentheses on both sides, so let's go ahead and start getting rid of those. Distributive property here. So we have 7a plus 7. And then bring down your minus 3a, your equal sign, 5. Let's go ahead and do distributive property here. Bring that down, plus 4a minus 4. Then combine like terms on both sides. So I'm going to have 7a minus 3a, 4a, and then bring down the plus 7. On this side, 5 minus 4, 1, and bring down your plus 4a. Notice you have variables on both sides, so get those together. But if you'll already notice here, this is similar to the example I gave you previously, where we had the same variable value, 4a, but notice that these numbers are different. So there's no way that 4a plus 7 can be equal to 4a plus 1. So you know right there it's going to be no solution. But let's say that you kept going with, the steps that have been drilled into your head year after year for solving. Then your variables would cancel on both sides. And you would be left with 7 equals 1. Now, please do not write 0a. I see that a lot of times during these problems, like students want to be like, oh, well, that's 0a, and think that there's still an a there. There's not an a. So 0, if your variable cancels 4a minus 4a, that goes to 0. 0. Anyway, so no solution. So you can just use the empty set, or you can say no solution. Any of those answers, or either of those answers is fine. Don't you guys love math and solving equations? It's fantastic. Okay, another type that I want to show you before we move on. This is one of my favorites. Before we move on to inequalities, trick that I will show you how to clear fractions. I mean, I know you guys love fractions, right? But I'm going to show you how to get rid of them if you have them in an equation. So this is a pretty cool trick, and you will encounter fractions a lot in Algebra II trig as well as pre-cal. Okay. All right, I have x over 4, or you can consider this 1/4 x, either way. Plus this plus that equals 13. So this definitely looks nasty to begin with. All right, here's a way that you can easily clear out the fraction, though. I want you to look at all of your denominator values. So your denominators are 4, 2, and 3. What you want to do is find the least common multiple of them. So you need to think, what is the highest number, what is the lowest number that 4, 2, 3 will all multiply to? All right, let's think about 12. All right, we know that 4 times 3 is 12, 2 times 6 is 12, and 3 times 4 is 12. So we're going to use 12. Sometimes if you don't get the actual least common multiple, that's okay too. It'll still work. Just make sure it's a number. So, and you're going to see in a minute, we're going to use 12 in some way. But make sure all of your denominators will go into or divide into that value. All right, here's how you clear fractions. This is going to be beautiful, so hang with me. Take and multiply everything in this entire equation by 12. So you're going to multiply every term. You have 1, 2, 3, 4 things in this equation. They all have to be multiplied by 12, or of course it's not equal. All right, for this first particular step, you think how you multiply this. 4 will go into 12 3 times. So 4 and 12 cancel, and you're left with 3. So then you multiply 3 to x. How many times will that go into 12? Whatever's left, which is 3, multiply it to your numerator. So 3x. Here, how many times will 2 go into 12? 6. So then 6 times x. 6x. So 2 and 12 cancel. How many times will 3 go into 12? That's 4. But then you have to multiply 4 to x. So plus 4x. And then, of course, 13 times 12. Mm-hmm. 156. And see, now we don't have these nasty fractions of x fourth, x squared, so on. This is what we're left with. A beautiful, like, two-step equation. Let's go ahead and combine all of these like terms here. So that's going to give you 13x equals 156. And you just determined 13 times 12 is that. So divide both sides by 13. And x equals 12. All right, let's switch gears. Last but not least, let's talk about solving inequalities. Okay, some things to recall about solving inequalities. You solve them similarly to an equation. So solve it very much like an equation, except for there's 1 or 2 rules that you have to remember. Let's see if you recall them. recall when you multiply or divide, both sides of an inequality by a negative value, does anybody remember what you have to do with this sign? You got to flip it. So multiply or divide both sides of an inequality by a negative value. Then you flip your symbol. Flip your symbol. Cannot stress that enough. That is one of the most common mistakes I see that people, simple things. It's one of those simple things in math when you forget to do it, and yet you've done, 5 or 6 steps of work and you forgot to flip your symbol, so it makes your answer incorrect, and you want to, of course, just rip your paper to shreds. So I've been there. I know all the math frustrations that you've encountered and are going to encounter. That's why we love math, right? Okay. Now, another thing really quick before we go on to the next page. We are going to practice. So instead of leaving our answers in like x is greater than 4, we're going to put our answers in interval notation. So please read the directions. If it says put in interval notation, please do. Put our answers in interval notation. All right, let's rock and roll. All right, this will be number 4. We have 7 times a plus 1 minus 3a equals 5 plus 4 goes. Wait. I'm looking at the wrong problem. My bad. Sorry. Okay, that's pretty long, lengthy, but we love it. First, before you, just don't even pay any attention to the inequality sign. All right, we're not going to worry about that to the very end. That's the way you work with these inequalities. Just carry down the inequality sign and solve it like an equation, keeping in mind the only time you do worry about this is when you flip it. Is if you multiply or divide both sides. All right, anyway, let's clear the grouping on both sides. Be very careful on this side. You've got brackets, so we need to clean up anything inside brackets first. So let's look in here. You need to actually distribute this negative sign to both terms inside. So let's bring down the 3. Bring down that bracket. Do not forget to bring down grouping symbols. If you leave that off, then this will turn into simple addition and subtraction. I see that happen. And it's not. This is 3 getting multiplied to everything you clean up inside. So we've got 1 minus x. Once you distribute, parentheses go away. Remember to keep that in mind. Negative times negative 2, positive 2. And then in bracket. Bring down your grouping. Let's go ahead and distribute negative 4 to both terms there. So 3 minus 4, negative 4 times 1, and then negative 4 times negative x, positive 4x. Okay, so on both sides, take care of any grouping. Combine like terms. Let's clean up. We still need to combine like terms inside here. So we're going to bring down 3. I'm going to go ahead and change this to parentheses. You can leave it bracket if you want. Then we have negative x, and 1 plus 2 makes 3, of course. Bring that down. Let's combine like terms on this side. That will give you negative 1. Bring down 4x. Then, of course, you still have grouping here. So let's distribute 3. 3 times negative x. 3 times 3. Bring down your symbol. Then we have negative 1 plus 4x. So finally, we've cleared grouping, combined like terms on both sides. Now we need to worry about getting our x's on the same side. It doesn't matter which one you choose to move. I like to keep x, or my variable, positive. So I'm actually going to add the 3x to this side. Bring down your 9 that's left on the left side. Bring down negative 1. And then, of course, that will give you 7x. And then we have a lovely two-step equation. So add 1 to this side, you get 10 is less than or equal to 7x. Last but not least, we're going to divide by 7. We did not, our 7's positive, so we don't have to flip our symbol. Well, I shouldn't have said that. Okay, I see students mess up a lot on this equation because your x is actually on the right side of your symbol. Make sure that you read that properly. So what I always like to do, if my variable is ever on the right side, this is also the same as x being, notice that the big mouse opening towards x is greater than or equal to 10/7. So do you agree that those are equivalent? All right, but our last step, we have to write, remember, we're going to write our answers in interval notation. So this is what that looks like. So this is what we're writing in interval notation, every number greater than or equal to 10/7. Once again, you can use a number line to help you visually see it. You don't have to use a number line for it, but you can. Okay. I'm going to always just sketch a short little number line. I'm going to put 10/7 here in the middle, and then think it is shaded in, because you got the equality part shaded to the right. Then all I have to do now is finish putting that in interval notation. So it goes left to 10/7. That's the farthest it goes, and then it goes right forever. But what do you use around 10/7 and I almost said it. What do you use around 10/7 and infinity? Remember, infinities always get a parenthesis. This is shaded, so it gets a bracket. This is shaded, so it gets a bracket. This is shaded, so it gets a bracket. Bracket shaded, bracket shaded. And yes, I would do that to you if you were in class. Okay, so guess what? This is my answer. This was our answer, of course, but we went ahead and put it in interval notation. So that's what you circle. Don't you love having to go that extra step? But I'm telling you, in pre-cal, we use interval notation in every lesson, and we do a lot in Algebra II with trig. So just take a deep breath. I know you're trying to process a lot, but it will definitely get better, and you're going to do great. Okay, our next inequality. Okay. You've got parentheses, so let's go ahead and distribute that negative sign to both terms. Bring everything else down just like it is, except for this part. So that's going to become negative y minus 1, or minus y minus 1, either way you want to say it. I want you guys to notice something. Notice you have the exact same variable with the exact same coefficient, which just simply means the number in front of it. So we got negative y, negative y. If I get those together, let's say you do that. All right, if you add y, it goes away here. Do not write 0y. It goes away here. Do not write 0y. And you are left with 10 is greater than or equal to, and of course 8 minus 1 is 7. So I want you to think about that. All right, recall, if we're left, even in an inequality, if you're left with a true statement or false, all right, if it's a true statement for an inequality, we're going to say negative infinity to infinity, or you can write double bar R, because it will be all real numbers. If we are left with a false statement, we're going to say no solution. But in this case, you need to think, is this true? So is 10 greater than 7, or is 10 equal to 7? Now, a lot of students want to say that this is false. And I'm going to tell you why it is actually true, and our answer in interval notation is negative infinity to infinity. This is an or statement. So it's just like if I said, okay, you can, all right, we're going to order pizza. You can have either pepperoni or cheese pizza. Well, let's say that, all right, that's not saying that I can't have either one of them. So in the same sense, you've got to see, does this satisfy either condition? Is 10 greater than 7, or is 10 equal to 7? If either condition is satisfied, it is true. I know that kind of makes your brain think a little bit, but okay. All right, that concludes lesson 1.1.